on these next two problems, I'm going to be focusing on what calculations to do rather than how to do the calculations. If you need help doing cross products, see the previous video. Here on the A part, we're asked to find the area of the parallelogram. So if we've got a point here, like point A, and a point B, and a point C, somewhere out here there's going to be a point D, so that this makes a parallelogram. Now, they didn't ask us to find what that point was, so we won't mess with it. However, the formula for the area of that parallelogram is this. If we take two adjacent vectors of this parallelogram, like this one and this one, the cross product of those if we do the magnitude of that, we get the area of the parallelogram. And that's indeed what they're asking us to do out here, is to use AB and AC. Now again, you can do this on your calculator. Again, I'm not going to spend the time with that. But the vector from A to B, as you see from up here, A to B, is going to be the vector -1, 2, 3, and the vector from A to C, is going to be the vector -2, -1, -4. And so if we do the cross product of those, and then do the magnitude of that, we get a 5 square root 6. Now, I did that on my calculator. The B part is asking us to find the area of the triangle ABC. Well, if you look at the diagram, here's the triangle ABC, and it's nothing more than half of the parallelogram. So we take what we just found and do half of it. So that would be a 5 square root of 6 over 2. And on the last part, that one is a little trickier. We're asked to find the distance from point A, here's point A, to the line through the points B and C. That's this. So we want the distance between that point and that line. What they mean by the distance between that point and that line is that we want the straight line distance, perpendicular distance from those two. So let me kind of draw this, something like what we saw in the book and on my videos that I showed you from the section. Here is the line from B to C, like we got drawn here, and I'm going to put the point A somewhere up here. Now this looks a lot like what I put in the videos where I showed you for this section. Here is the vector from B to A. If we look at this right triangle right here, this side of the right triangle and this side of the right triangle can be defined in terms of this angle. This side is the magnitude of BA times the cosine of the angle, and this side is the magnitude of BA times the sine of the angle. Now, we had in one of our videos a list of properties for the cross product, and one of the properties said that the magnitude of the cross product of u and v was the magnitude of u times the magnitude of v times the sine of the angle between them. Now notice that's very similar to the dot product relationship. However, this right here is what we have here. And that happens to be the length of the side that we are looking for. And so to find that, we simply divide both sides by the magnitude of u. Okay? And so for ours, in terms of these vectors that we have, this magnitude of u cross v, that's what we just found, and this happens to be the magnitude of BC. So we need to know the magnitude of BC. Now BC is 1 minus 2, negative 2 minus 1, and negative 2 minus 5, which would be the square root of 1 plus 9 plus 49, which would be the square root of 59. And so the length of that comes out to be a 5 square root of 6 over a square root of 59. Now I guess we don't need that in approximate form, so that we'll pronounce as our answer. Now on this last one, again, there's a special relationship. I'm not sure if I have it in the videos. You may have to look at the textbook to find it. We got a thing that we're looking for here called the torque. So the idea here is the torque uses the Greek letter tau, kind of looks like a T, and its definition is it's the magnitude of the cross product of this vector and this vector. This is the R and this is the F. And the main problem here, other than doing the calculation for the cross product, is to actually find the R and the F. So here's our R vector. It's at an angle of 30 degrees with the horizontal. We've done this before. That's going to be, and by the way, this is in foot-pounds, so this 12 inches is 1 foot. So this is a 1 cosine theta and a 1 sine theta. And we'll use 0 for the z component since we're in 2 dimensions. And the theta is the 30 degrees. So our R is a 1 times the cosine of 30 degrees, 1 times the sine of 30 degrees, and 0. Cosine of 30 degrees is square root of 3 over 2. Sine is a 1/2, so here is R. Now F is this vector. It's going straight down, 10 units long. We write that as 0, negative 10. And again, there's no z component, so we'll just use a 0 for that. So now we need the cross product of R and F, which again we can do on our calculator. This is a good instance for me to show you doing this by hand, however, because look, all these zeros, it's going to make it kind of convenient. So here's our cross product. We put the I, J, and K. This is square root of 3 over 2, 1/2, and 0. This is 0, negative 10, and 0. When we expand, here's my I component and the determinant for that. If we cross out the row and the column where the I is going to be a 1/2, 0, negative 10, 0. That's 1/2 times 0, negative 10 times 0. That's all 0. So the I's are just going to disappear. And for the J component, we're going to have the determinant, square root of 3 over 2, 0, 0, 0, which is also 0. That's going to disappear. For the K component, we cross out the column and the row where the K is. We get square root of 3 over 2, 1/2, 0, negative 10. Well, the 1/2 and the 0 is just a 0, so we end up with square root of 3 over 2 times negative 10, which comes out to be a negative 5 square root of 3. So the vector r cross f is actually a 0, 0, and a negative 5 square root of 3. Now you should be able to tell by looking what the magnitude of that is. So I won't do all of the calculations. That's a positive 5 square root of 3. Now they did want this rounded to 2 decimal places. So if we type 5 square root of 3 on our calculator, we come up with an 8.66. And of course that's in foot-pounds.